Welcome to the third webinar of PennTAP's Building Retuning and Energy Sustainability series. My name is Alana Colvin. I am an Energy and Environment Technical Advisor with Pennsylvania's Technical Assistance Program, or PennTAP. This will be the final webinar of this series. During this webinar, we will discuss Building Retuning, or BRT. I will give a brief introduction on BRT, what it is, and what the principles are. And then I will review the investigation phase of BRT, provide walkthrough guidance, talk about a few low-cost, no-cost tools, and discuss continuous improvement strategies. Afterwards, I will go into greater detail about PennTAP and our background. What is BRT? Building Retuning, or BRT, is a prescriptive approach to identify and correct no-cost or low-cost building operational problems that lead to energy waste. The purpose of this webinar is to train participants on how to make your buildings more efficient, which can lead to energy savings and reduce operating costs. The principles of BRT are simple. If you don't need it, turn it off. If you do need it, run it efficiently. Your aim is to learn your building's personality so you can get the results you're looking for. Know where your occupants are and at what time of day. Adjust your controls on your energy systems to reflect your real needs. Supporting continuous training of the staff and occupants so that you're successful in reaching your goals to reduce energy costs. There are 5 steps to BRT: data collection, investigation, implementation, documentation, and sustain. In order to implement a BRT program, you need to take time to complete each step. PennTAP will be guiding you through these steps to support not only the retuning of a single building, but of the whole district. For data collection, you want to gather your utility bills, applicable maintenance logs, O&M manuals, etc., to see if there's a trend in your energy consumption. You want to understand your building's baseline, the current energy consumption, and the timing of the various operations that go on within your building. Once you have the data collected, it's now time to investigate. Complete a walkthrough of your building, looking at your building's conditions and operating costs. You want to log all information and observations during your walkthrough. This will help capture any energy-saving opportunities. Post-investigation, you should have a working list of opportunities. Employing implementation will positively impact your baseline. Documentation is actually more or less a responsibility after each of the 3 steps we discussed so far. Documentation is a combination of reporting the building retuning findings, your impacts, and the changes. Once you've completed your baseline, investigated your systems, and have a strategy to implement your projects, you'll want to improve continuously and thus sustain your efforts. You can achieve this in many ways. Consider an energy management system for your facility or a preventative maintenance plan, and/or continue to use benchmarking tools such as Portfolio Manager or the Energy Asset Score tool. Listed here are the common systems relatable to all building types: building envelope, HVAC systems, air distribution, lighting, hot water, office equipment, and indoor environmental conditions. During a building walkthrough, you are purposely going through your building, collecting information to identify operational problems and energy-saving opportunities. It is important to be thorough and to validate assumptions. Questions to consider: is the system doing work as intended? Could it be working in a more efficient manner? In the second BRT webinar of this series, we went into more detail about these systems and the methods to investigate them. For this webinar, we are going to break down some helpful low-cost, no-cost tools to support you on your walkthrough. Some tips for the building walkthrough: investigate all building conditions and operations using your senses. Look, listen, smell, touch. Remember to investigate during times that include both occupied and unoccupied hours, the times when space is being used during nights, weekends, or even during holiday breaks. Consider investigating 2 times a year, once during the heating season and then again during the cooling season, and if applicable during the shutdown periods. Remember to log all of your information and observations. This will help capture any potential energy-saving opportunities. Everyone has their favorite tools. Sometimes all you need is a hammer and a little persuasion. Other times maybe a bit more forethought is necessary. But to get the job done, you'll need tools to do it. Up next, we'll discuss some handy, simple to use energy tools that can help you identify opportunities during your walkthrough. Measuring tapes are always handy, but for some variety in your toolkit, consider the kilowatt. The kilowatt is an electricity usage monitor. Think you have a sinking cost for a piece of equipment, like maybe those fancy coffee makers, the vending machines, maybe the charging docks. You can use this tool to understand how much electricity equipment is using, which can do one of two things: support your argument to implement new controls or upgrades, or ease your mind that the equipment is operating in an acceptable way. During your walkthrough, you can find out more about your operations using these smart tools. These tools connect to your smart devices, such as a tablet or smartphone. We will be reviewing the HVAC smart tools and the infrared cameras. To take advantage of these smart tools, you will need to download these apps to your smart device. Siik Thermal is the app for the infrared camera, and CPS Link is the app for the HVAC smart tools. Both of these apps are free, and you can download them to your device prior to buying any of these products. First up to discuss are the AAB Smart HVAC tools. So after downloading the CPS Link app, these environment loggers will provide real-time feedback through a Bluetooth connection to your smart device. Through the app's dashboard, you can set a name for the tool and also set how often data is taken, and then you can download this data onto an Excel spreadsheet, which then you can plot and review for trends. Is there a staff member you know who is always too hot or always too cold? Do you think you might have a leak in the ceiling, or is an area damp? That might be a current issue, or maybe it's just a stain from an old previous issue. Use these tools to investigate. Nearly all facility buildings have heating, ventilation, and cooling in rooms, hallways, and throughout the specialized rooms, such as cafeterias and gyms. There are the larger air handling units, but those are less tedious when it comes to managing the filters. But do you have any wall-mounted units in your classroom or in your lobbies? When was the last time those units were cleaned? Is it worth breaking down a unit to clean it? These AAB airflow meters can help you decide on a strategy. Just like the environment sensors previously discussed, these Bluetooth sensors can collect airflow information, and you can download and review the results to make a decision. The Siik thermal camera is a specialized thermal sensitive camera. This tool is made for any smart device and will accurately capture heat map data. Find problems like air leaks, broken or missing insulation on pipes or behind walls. You can use this tool to investigate your building envelope. In the top left photo, we are looking at a building's envelope. In the picture of the building, we can see that some of the windows are cooler than others. Maybe they're open, or maybe the seals on those windows are failing. This would be a low-cost, no-cost opportunity to correct. The camera has supporting information for you to investigate that stairwell or room, and there is opportunity to correct this loss of energy and to make a difference. In the bottom photo, we see that the corner of the room has either damaged or fallen insulation. From this perspective, we see that the cold air is creeping in. But why? Is it possible water damage? Or maybe the insulation was poorly installed? Regardless of how the installation failed, you did discover an energy sink, documented the issue with the camera, and now you can make a plan to implement a fix. In addition to the handheld tools, there are calculations that support building retuning initiatives. I am going to walk through a scenario for lighting. A school building has a standard fluorescent lighting system comprised of 34-watt T8 lights with a standard ballast in a 4-lamp troffer. It is proposed to install 4 18-watt T8 LEDs in the existing fixtures with no ballast. Estimate the energy savings in dollars and the simple payback of the system if it operates for 4,000 hours per year and has 100 fixtures. The demand charge used in this calculation is $10 per kilowatt, and the energy charge is 5 cents per kilowatt hour. An installed LED fixture is $50. Feels like a lot is going on in this scenario, but let's break it down. We are going to be looking to determine energy savings in dollars and the simple payback. So to move forward with this problem, we need to determine the energy and demand savings. We know that for the existing lighting, there are 100 fixtures. The lights are on for 4,000 hours per year. Each fixture has a ballast. Each fixture has 4 light bulbs, and that the light bulbs are THs, which consume 34 watts each. We know that the ballast impacts energy consumption through the ballast factor. So in this case, an existing troffer consumes 156 watts. We also know for a new LED fixture that has no ballast, it will be a 1-for-1 bulb replacement with 18 watts per bulb or 72 watts per fixture. We also know that the cost for 4 new LED bulbs is $50. From the utility bills, you can see your demand charge and energy charge. In this case, we are using $10 per kilowatt for the demand charge and 5 cents per kilowatt hour for the distribution charge. So as suggested, we will calculate the demand savings and the distribution savings. 156 watts minus 72 watts is 84 watts. Times 100 fixtures gets you 8.4 kilowatts of demand energy savings. Take the kilowatts you are saving and multiply this by the time in hours you are running the equipment for 1 year. 4,000 hours per year gets us at 33,600 kilowatts per year in energy savings. To determine the cost savings associated with the demand and energy savings, we need the values from your utility bills. To convert to LED, we are saving over $1,000 on our annual demand charge and $1,500 on the annual distribution costs. The total savings is over $2,500. To determine the payback, you need to take the cost of the new equipment, in this case 100 fixtures times the $50 for each upgrade is $5,000 for the implementation costs. Divide that by your annual savings. We'll have a payback of just under 2 years. To tackle lighting, walk through each classroom, utility room, hallway, specialty room such as your gyms or library. Count your fixtures, the number of bulbs per fixture, and understand the watts for each style of bulb being used. You can set up a table to calculate the lighting information based on the investigation walkthrough. Here, you can see how much energy your lighting is consuming annually. Once you have what currently exists in your building, you can prioritize each bulb project to tackle first, which project to tackle first, by estimating the cost savings from replacing your existing bulbs with LED. Every bulb consumes energy differently, and maybe there are strong behavior controls in place to justify the priority of which specific lighting project to start with first. Remember, you can always determine the project paybacks just like we did in that example problem. Just take that example and scale it to as many or as few rooms you're looking to upgrade. This gives you evidence that there are energy saving and cost saving opportunities to consider and allows you to present your case in a logical, well thought out order for the rest of the team to review. So, overall, what does it look like when you complete a walkthrough? Documenting your walkthrough does not need to be an overly complicated process. What you want at minimum is the area that you saw the opportunity, the category of that savings opportunity, and what was the opportunity. Give yourself some hints to remember. And then it's suggested to simply a simple approach to prioritizing the order of tasks would be to estimate the level of effort and to estimate the potential savings. These do not have to be facts, but it gives you a way to prioritize your project. The intent for you is to capture several low-cost, no-cost building opportunities. These opportunities will add up, especially when you consider not just one building, but completing this for the whole district. These savings will add up and not only positively impact your baseline, but also support the longevity of your building. For other systems in your facility, the Department of Energy, DOE, offers many energy and cost-saving calculators for energy-efficient products on their website. These can help you calculate savings for other projects as well. To complement your BRT strategies, an energy policy at your school will help highlight your best practices. An energy policy is really the framework for efforts made by the operations team. The energy policy should highlight a trending goal for the district, and through your efforts, you and the district will be able to achieve this goal. Now I'm going to give a brief overview of PennTAP. PennTAP was established in 1965 as one of the nation's first technical assistance programs. PennTAP is a federal, state, and university partnership that was originally created to help stimulate statewide economic development. PennTAP helps organizations maximize their competitiveness through in-person consultations, unbiased technical advice, and connections to Penn State experts, resources, and programs. We focus on helping firms that normally do not have the in-house expertise or resources to resolve specific technology questions or needs. There are currently 2 different service areas within our technical advisors that we focus on: energy, environment, and innovation. PennTAP has the 2 pillars, which we offer our service. Under energy and environment team, we offer P2, E2 assessments, E3 assessments, and energy management system support. And we also provide the BRT program under this pillar. We then offer the innovation opportunities as well, which covers products and process improvement, the learning factory, and student entrepreneurship. Pollution prevention and energy efficiency, P2, E2 assessments. Our technical advisors perform pollution prevention and energy efficiency on-site visits, provide recommendations for improvements in energy utilization and waste reduction, prepare and deliver on-site assessment reports, and provide assistance in completing grant applications for project implementation. This is no cost for PA manufacturers with fewer than 500 employees, but we also have, subject to adequate funding, we can perform fee for service based on a customer's need. The E3, Energy, Environment, and Economic objective is to help Pennsylvania manufacturers define and implement strategies designed to improve energy, environment, and economic efficiencies. Our technical advisors will perform pollution prevention and energy efficiency on-site visits featuring activities in which lean manufacturing techniques are applied to focus on energy and environment issues as well. It includes E3 training for the team of employees, followed by the P2, E2 assessments conducted under the direction of a PennTAP advisor. Energy management systems, or ENMS. An ENMS is designed to help an organization take on a strategic approach to achieve continual improvement in energy performance by creating a framework to integrate energy efficiency into an existing management system. And ENMS can help you establish the policies and procedures to plan, identify, prioritize, and implement projects that will improve your facility's energy management performance. The highlights for 2017 for the Energy and Environment team: we conducted 79 on-site assessments, E3 events, BRT sessions, and ENMS trainings. We have also reduced greenhouse gas emissions by 1.8 million kilowatt hours. Economic benefits include 4.3 million for Pennsylvania And also to highlight, we had 108 attendees from school districts and municipalities for the BRT last year. For the innovation pillar, we have the US EDA University Center program. PennTAP is able to, with this program, PennTAP is able to enhance and build economic development in Pennsylvania by leveraging Penn State resources with businesses and community partnerships. We do that by engaging students and faculty in technical design and operational efficiency projects to help entrepreneurs and intrapreneurs overcome hurdles. There are over 21 innovation hubs located at PSU campuses around the Commonwealth to help new businesses and product creation. The Learning Factory supports hundreds of student team engineering design projects every year and helps support advanced technical challenges to discover viable solutions. The Learning Factory has been engaging students for over 23 years. The Learning Factory allows students to demonstrate before graduation their abilities to perform in the work environment. It allows organizations to build engagement networks with the faculty and the staff within Penn State, and also allows small companies to benefit from the inexpensive but high quality engineering services at Penn State. It also allows companies a long-term interview with potential students they might want to hire after graduation. The PennTAP Innovation successes for 2017 include over 100 students participating in the entrepreneurship and Learning Factory opportunities. The IncU granted $30,000 in grants towards student startups, and PennTAP was able to support 21 companies on collaborating with Learning Factory projects. I would like to acknowledge the Pennsylvania's Department of Environmental Protection, or DEP, and the Pacific Northwest National Laboratory, PNNL, for supporting PennTAP and for supporting the BRT performance. Thank you for participating with this webinar. If you have any questions or comments, feel free to contact me. If you would like to learn more about PennTAP, you can visit our website at pentap.psu.edu. Thank you.